Hello, everyone. Welcome to this week's presentation of DBA Fundamentals. Welcome to Continuous SQL with Kafka and Flink with Tim Spann. Today is, as it says on the board, February 20th. We're going to have all kinds of fun with Kafka today in SQL. As you see in the top right-hand corner of the screen, the three leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you ever need to get hold of us for any reason, you can easily get hold of us via our Twitter handles, or X as it is now. Below that, you'll see many of the ways to get a hold of us on social media. First up is on Meetup, where most of you, if not all of you, found us and were able to get the link to our Teams group. Below that is our website, dbafun.com, where you can find anything having to do with us. You find our past presentations as well as upcoming features, all listed there for all of your entertainment needs. Below that is what we like to call the DBA FunTube. It is where you can find all of our past presentations as well as this one as soon as I get it uploaded. It's as I said, you can find all of our previous meetings. Be sure to like and subscribe to us so that you can know exactly when I've placed it out there for everyone to watch. Below that is also our Twitter or X handle, DBA Fun, Slack channel, and our LinkedIn group. Some of our upcoming conferences that we all should be aware of, or at least know they're out there, and be willing to, if you have a chance, be sure to go to them if you can. There is SQLBits 2024, SQLBits 2024 on March 19th through 23rd at SQLBits.com. You can find out more about it. Or Microsoft Fabric Community Conference in Vegas, the 26th through the 28th of this year. Put on there the website for it if you would like to go to it. If you still haven't registered, please be sure to use the code Azure Data Community for $100 off the registration price. Please remember to turn off your video and mute yourself if you haven't done so already. I'll do so here in a minute so we can focus on Tim. And please be sure to type any questions you have into the chat because I'll be monitoring it and passing them on to Tim for him to answer. As always, we have Tim's little bio, so I'm sure Tim has a much better one, all prettied up for us to look at. So, Tim, I hand it over to you.
Okay, great. Let's share this content. Hopefully all is good. Everyone can see my screen.
We can.
Awesome. Okay, so we will dive into some of the differences and what exactly does continuous SQL mean. And it is something that works really well with other databases, especially in certain use cases when you're getting data as it changes from different databases, getting that into a stream of events and then processing it while it's happening, which is interesting. And we'll show you that. I do a lot of this sort of thing. A lot of it's IoT, real time, ML's in there, different databases, different programming languages, lots of things. I've been around big data, data streaming for a while, all the data stores, all the databases. Once a week, I put a newsletter out. It's about as easy to consume it that you don't even have to get it emailed to you. It just shows up in GitHub, and it covers all kinds of cool open source stuff. I do my own meetups in New Jersey, New York, Philly, plus virtual, covering all data streaming, ML, AI. I think I have one end of this month. So we're going to go through an introduction, probably this, overview of different parts, cover the different streaming projects. What's nice is all of this is open source. So regardless of where or how you want to run this, you could run this on premise, you to run it in a virtual machine, in Docker and Kubernetes, bare metal, Azure, hybrid, any place you want. Pretty easy to run all or parts of this depending on what makes sense for what you're working with. And of course, there's official supported versions in Azure, as someone would expect. And there's a couple vendors do their own versions of this as well. They call this streaming analytics because the data is in movement, and we'll show you that. The nice part is it's regular ANSI SQL 92. There's nothing, very special in there. Maybe a couple keywords show up, but if you know SQL, you'll be like, oh, there's a join, there's order by, and a where clause. Same as always. We'll go through as many demos as are working. Show you some resources. It says Q&A at the end. If you're comfortable with that, do it then. If not, if something comes up, let's address it right away. Some of this stuff is a little different or maybe a little odd. So it'd be good so you're not, on the wrong page to start with. Now, when you're doing real time, it'd be nice if there was one box that did everything. There really isn't. There's a bunch of different projects that do different pieces of this. And of course, you can plug in any number of computer languages around this, any number of databases, data stores, lots of sources of data. But generally, we can't just do it with one tool. It'd be nice if we could do it all with Kafka, but we tend to need also Flink, which is the magic behind the continuous SQL part. And you'll see now it's all the vendors out there are combining the two in one way or another. And then this is our secret sauce, Apache NiFi, that lets us get data into a stream very easily, regardless of where it's coming from, which is nice. And a couple other data stores listed in there. Now, unfortunately, because streaming works in, these different pieces, and you may have heard of like Spark, well, when do I use X or Y? For Spark, and again, which Spark runs in Azure and everywhere else, this is really great for batch. And this tends to be, if you got a huge amount of data in some databases or other places, get them moving through the system in batches. This is also nice with Spark. There's a lot of ML and Python support. So you could do a lot of different things to the data, a lot of ETL. Really nice way to load your data and load it anywhere, even if it's multiple places. Easy to, set that up in schedules with something like Airflow. It is great for that. So if you have batch data and you want to move it around, this is the modern solution. Spark is well supported. Lots of vendors have it. Native to Azure and all the clouds. Very easy to do, and again, open source. Now that tool you might not have heard of, NiFi. NiFi is nice because it can do lots of simple JDBC stuff, and we just brought in the open source community Debezium there, which is the magic for change data capture. So this will be able to support this, and this is drag and drop. So this is a really nice way to do very low code, run it anywhere, run it at scale. And there is a lot of work behind this project, including Microsoft is one of the people in the open source on that, supports a lot of different data sources. And it's usually the easiest way to get things started into a stream. Once you get into a stream, you can do a lot with it, but you need to get it going. Things like Flink and Kafka are good for that, but you got to do a lot of low-level stuff if it's beyond the handful of really major connections and sources. Things like Kafka, all the major databases, those are major sources, so you could plug right into them with Flink. But for the most part, anything else, you're doing some coding. So want to have someone who could do that for you, do that with NiFi. And we'll show you them all working together. So Flink is good because it's very low latency. You could do some really advanced coding. It's very fast. It can join live data streams, which is really cool. And also join them to what we'd call a batch stream, something like a database. So I can join SQL Server tables right to a Kafka topic if I wanted to. And obviously, there's a little bit of a mismatch in speed, but Flink handles that for you. So when a new event comes in, it can match it to what data you already have, even if you're using that same data stream to update your SQL Server tables, you could still have the joins update. I mean, there may be some latency in how long it takes to update the database because you probably don't want to insert one record at a time. You might be doing a batch of 100, 1,000, a million, depending on how big a amount of data is coming into your database. But that's all supported with Flink, and it scales out really large. Anyone coming from Asia will know Flink because it runs most of the major cloud transactions. So for Alibaba and a lot of the other major clouds over there, most of the major data processing is done in Flink because it scales out to, I don't even know the max limit, but petabytes of data, thousands of servers, millions of transactions, whatever you need to push through it, it can handle it. And a common infrastructure now that people are starting to do more and more AI. And this could be running on, like I said, multiple clouds, or if you have a single cloud or on premise, however you change it, it doesn't really matter. What's nice is it's very easy to distribute data between different places using either NiFi, Kafka, or some other cloud tools let you push data around if you're storing it in like object store. But there tend to be some of the data we work with, and that is one of the nice features that NiFi also adds to the table is the ability to work with non-structured data. So not just table data, but logs, you know, video, images, live question and answer, PDF, Word documents, anything you see here, regardless of where it's coming from. I could pull from, you know, Microsoft drives, Google drives, object stores, wherever your data is, get that into a stream live, do some enrichment and routing on it. If I need any real-time alerting, I could do that there. Get that into Kafka. Kafka is basically just a message queue. It's a little more a little different structure to it, but that's the basic idea. As soon as I get data ready, or even if it's raw, get it into Kafka. So now I could distribute it. So we're not tied to one thing. So I don't have to wait. Once I have it in Kafka, as many people want to consume it as once they can, and they have control of their own speed that they want to pull it. So if I want to pull it in a batch and push it to a data store, I can push it to any kind of data warehouse in chunks and work whatever tool I want to use there. If I want to pull it in event at a time in real time, I could do that with Flink and do real SQL with that, real visualization. That same data can be pushed into vector databases and to other places to help train or run predictions against your data, whether it's regular machine learning, uh, deep learning, or even LLM, large language models, generative AI. Doesn't really make a difference, though pretty much only Gen AI is working with these vector stores. And it's very easy for us to get the data chopped up and put in there again. And then once it's chopped up, I could literally start joining that data to your table data and do that in real time, which is kind of cool. A couple of examples. Oh, I didn't know this one loads. Okay. Bunch of data sources, sometimes real time, say coming off a car, coming off vehicles, plus joining that to things that are coming out of database. Run real time analytics to say, hey, something's overheating, something's going to wear down, something's happening. And then store that all in your various data lakes, lake houses, and databases, and then use that for whatever other regular analytics you have. But being able to use that same data for real-time decisions and decisions that have a ton of data that needs to run bigger analytics. You're still going to have your bigger reports that may take longer. And to me, long time is a minute. So if it's a minute or longer, get that out of the real time. Though we can do windows within Flink, so I could look at what's happened over the last 10, 15 minutes and say, okay, someone's used this credit card 12 times in the last 15 minutes, and I check a SQL Server table that says that's not typical, and I could send out a real alert or send out an action to stop that card, send out the alert saying, hey, this looks like fraud, you know, basic ideas. NiFi, or it could be anything gets the data into Kafka. I could use Spark to load the data. Flink can load the data. Any kind of application code, whether it's in C#, Java, JavaScript, Python, anything you got out there, you could use that Go. And once it's in Kafka, I could start doing real-time analytics on it, or whoever needs to consume that data could do whatever they need to do on that. Very nice way to distribute your data so you're not locked into it. You're not tied to that data source, which is important. So let's get through some of these. We'll show you these in the real world. Now, beneath the covers, really important is to have Kafka. The reason why is Kafka is acting as our data pipeline, our buffer, our message queue. This is, where our virtual tables are coming from. This is events, logs, messages coming out of databases, whatever comes in real, comes off a device, a phone, anything that comes in event at a time, or even in small, fast batches, it makes sense to put it into Kafka because Kafka can handle, petabytes of data and handle pushing it through really quickly as fast as someone on the other side wants to read it. So it comes in, comes out, lasts in a log that can be, changed the size of, can be expired. So you don't use, infinite space there, but can hold a lot of data. And what's nice is if your consumer of data stops consuming, maybe it crashed, maybe you ran out of space, or you're, shutting it down for the night so you don't want to pay for it, it'll stay in the queue and queue up in order. And semantics allow you to do things like exactly once, if that's how you want to consume it. So it'll stay there. You won't lose data. Like other systems like this, there has to be multiple copies of it. So it's stored on multiple servers. Again, supporting PubSub, scales out very well, lots of data. And you can break these up into topics, which you could think of as tables. I mean, some people make one topic support multiple tables. It really depends on your architecture, but it's very easy to think of it as I pick up a table worth of data, put it into a topic, and make it available as individual records going forward. But it really depends on what you want to do with it. The main part for Kafka is what you got coming in will come out in order. And unless your consumer doesn't support it, it can be exactly once. Obviously, if data is lost over the network, it'll be at least once. You can grab it again. You could also choose to go back further, grab older data and read it forward. And I'm doing that in one of our queries. I'm grabbing the first event I have in the Kafka topic, again, in order, so the oldest one, so that I can always have a lot of data. But you can change that. You could decide I just want what's happening now, and I don't care what happened before. You can also get that same data by joining to like a database table and getting all that data. It's great if you want to augment it, because sometimes these events, they don't have the details. You have an ID, you might have some fragment of the data, but it's nice to be able to look up the details from a database. Database can have as much data as I want, right? You could put petabytes of data, billions of rows in there. They're probably not sending all that data. So that's really great, especially like something like a credit card. It might just have an encrypted card number, an ID, what's going on now, timestamp. And then I can look up the important details on that account, on those customers from database tables. That is very helpful. Again, support for regular SQL, but being able to do it continuously. So as events come in, it just keeps running. It stops running when I don't feel like running it anymore. Or, there's no reason to run it. Maybe I shut it down at night for something, or shut it down if we're no longer doing that kind of processing. And as you can see, SQL looks pretty familiar. There's a couple things in here a little different. The tumble is how I do breaking up data into windows. And you might want to do that again. Credit card's the big one. If someone charges the card 15 times in 5 minutes, that is probably unusual. And then we could look at counts. Again, looks like regular SQL, pretty close for almost all use cases. Outer joins, all those kind of things in there. Couple of things that makes more sense for real time that we have in there. Now, right now, it's not an infinite amount of sources that you can access from this continuous SQL. Kafka being the biggest one, but also any database I can hit with JDBC, object stores, things like big data resources like Kudu and Hive. This is why we have something like NiFi getting into Kafka, so we can access and being able to do these real-time queries and being able to do pretty powerful results. Now, not everyone should want to connect to Kafka or to connect to Flink. So what's nice is within this version of Flink SQL, while we're running these continuous queries or aggregations, we can push these out to a REST endpoint as standard REST JSON data. And that can be made available to any kind of notebook or Spark or anything that can read REST and get that data in a more normal format. So you don't have to know anything about Kafka. You will get the most recent in-time data from that, which allows for caching for things that want to have data all the time, even if it's old. And I'll show you a couple of dashboards in HTML that I do for that. Again, that could be used for your mobile app. I might not be using my credit card every minute, but I still want to see the last, 20 transactions, even if I haven't bought anything recently. So that's important to have that. What's nice is Flink is integrated with Apache Iceberg, which is an open table format for storing massive data in different data stores like ADLS or S3 or on premise in something like Ozone. So you have massive data store that is very flexible, more flexible than these older formats. And Flink lets you connect to these as another resource, whether to stream data there, pull it out, or whatever you need to do, which is very nice. So we got a lot of demos. So I'm going to go through them and we'll have some wrap up code. Again, if you have any questions, definitely put them up either in the chat or ask for them. Not a big deal, but probably be more questions once we show you this for real. Wanted to show more in depth on a couple examples of queries. The top one is doing a group by with max, min, average on a stream of data coming off of airplanes. And we could just do this real time, which is pretty cool. This is coming from a Kafka topic. The one below this, and this will be the main demo, this query is joining a couple of different live resources. I've got a feed from the MTA in New York, which is the largest transit system in the US. They have, for this one, I'm doing buses, and I'm joining that with Transcom is a multi-state organization that publishes real-time status of roads. So is there an accident somewhere? Is this road closed? And that comes with a latitude and longitude. So I'm connecting all of these based on approximate lat and long. And yeah, there's functions I could use to make that a little better. And I can actually functions within this continuous SQL, but I go back and forth between them. Here's the function down here, distance between different lat and long. but let's get into some real code. Hopefully things haven't timed out or crashed. Then we'll get back into some slides and questions, what have you. Everything is in uh, GitHub, so if you want to access, try things out, I have all the examples, how to build the tables, the SQL, all the source codes in there for you to try out if you want. But let's go first here. Hopefully, maybe I have timed out. Okay. Oh, there we are. So this is Apache NiFi, which I mentioned before. This is how I get my data. I pull it off a REST endpoint and process it. It comes in as JSON. I make it a little cleaner JSON, and I have a query here that processes that and lets me output what I want. I split it out, add a couple extra fields. I like to add a timestamp and unique ID. Again, I could carry that ID through the entire system, through Kafka, through Flink, and then if I'm going to push it right to a database, you know, you don't have to come up with your own primary key. You could use the one I generated, or use that as a pseudo key if you want. So what I have here is I put in something to slow down my data coming in. Otherwise, it moves so fast you can't see it. And that's kind of boring. A thousand records went by and you're like, what did I see? So for demos, I slow it down. So I'm just sending that data at 1 or 5 rows a second just to make it so it's not super fast. And what's nice with NiFi here is this is not just something to show you what's going on with the data stream. This is the actual coding. It is these boxes we have here that run and do things like take my data, write it somewhere else, and run it in a different format if I want. So if I downstream system needs it in XML or a comma separated value or something like Avro, we could do any of that with the different writers there. Another thing that's pretty cool is I just stop the live data. Doesn't matter, I don't lose it. It sits here in a buffer, and I could just start it, stop it anytime I want. Or if I wanted to move this somewhere else, say Kafka was offline, you know, I could just say put it into a database. You know, if I wanted to push that data to SQL Server, yeah, you don't want, I gotta stop. Okay. So we'll stop it, it's backing up, and now I'll send it to SQL Server. I'll just create a connection pool, say what kind of statement it is, you know, insert or whatever, you know, what type of database is it, and push it to the one that makes sense. I don't have to write any SQL. It will translate things based on what it thinks the schema is, or I could set the schema, have that run as a legitimate schema registry, which will validate all the fields if I want, as flexible as you want there. And we can do that if we needed to. Like if I wanted to change this, I could come in and put in a schema registry, and it could be, I actually have one down here. This one's using Postgres, but I could use SQL Server. I could use whatever database you want. Just set up a connection pool to it with all my parameters here. Parameters can be stored in a lot of different places, different, however you like to do it with whatever DevOps tool sets them. And then that just is used to grab the tables and match it up and use the schema of the table to decide what's going on with my system, which is really nice. Pretty easy to do that. As you see, I'm doing a lot of other processing in this side, but that's really just to get the data into the stream so we can run our SQL. Hopefully that one hasn't timed out. If so, we could just go into another screen. This is another source of data. This is from the Transcom. Again, same idea. I have it paused because this is all running on my laptop along with Microsoft Teams and Chrome. Chrome probably takes more than all my servers combined, which is a little insane. But yeah, so I'm taking the Transcom data, and we can look at this data while it's in stream, which is pretty nice. if I slow it down. It's actually too fast. I'll look at what we call data provenance, which is the lineage of the data, how it changed. And here it told me it sent out one message. I can look at all the metadata for this data, where it came from. Again, this came from a REST endpoint. So I could see all that REST information there. It's JSON, all that kind of fun stuff. And then I can look at what the data actually is. And it is JSON. It started off as RSS, but I convert it into JSON, and it's that has a title, and I parsed out the Latin long so I know where it is. And it's got a timestamp, and it tells me that part of there's going to be construction going on. So that's useful information. Now I could push that to a language model that might want to parse that out with something else, and send that to a Slack group to tell people, hey, there's construction going on. Maybe taking the bus today is not the best option. Maybe you want to take the subway. And we've got a feed for the subway too, but just to give you an idea. Now, another feature of data we have coming from a REST endpoint is I have a source of speed cameras throughout New York, and that has the lat long for them. I'd pull out that lat long. Let's start sending that data. And this is just sending traffic data. So I've got this traffic data. This is all going into Kafka here, and I can browse Kafka, sort of like a topic, but here the data inside is JSON. So it's just a key value pair. That value could be anything, but this happens to be our travel data in New York. This is where different speed check cameras are, and I guess the average speed of people, how long it takes for things to go through it, what's going through there. And it's an interesting data store. Here I'm looking at those Transcom messages we mentioned. It tells me where there's problems on different parts of the road. It gives me that lat long so I could find them. This one is where the buses are traveling through New York, and we're getting data, every second for every bus. Where is it? How many stops it has to go? Pretty big set of data. And I have that. Let's get some fresh data here now. We're putting in here. This is the query I have to combine that speed data, the bus data, and the data for those notices. And I'm joining them with approximate location. There's different ways to play around with that. Again, I have a function I could use written in here that I can use, but I don't know. I'm not too big on functions, but this one does the math. It's probably a little better. I probably should switch to using that. But it's really, to me, it's the idea that they're close. So I've got a full outer join here between the MTA bus data, those Transcom notices, and then the traffic speed. I do that because otherwise, even with that close data, it's, it is approximate. There is a lot of data in there. And if we look, it's Kafka data, and it looks at that JSON and figures out what a table should look like so that I can do a SQL on it. And behind the scenes, Flink is running a lot of processing on this to join these different data sources together. And there's the three data sources, and this is running continuously. This is just on my laptop, but you could take the same code, put it into a bigger Flink cluster with, say, 1,000 nodes, and it'll distribute that evenly so you can support a lot of records. So you got those sources coming in, we join them, that gives us a subset of the data, and then we push it out as a stream of data. So, thousands of records coming down to less. And then on the other end of that, inside this tool, I can create a materialized view, looks at these columns, and then just pushes them out to a REST feed and lets you put in your own keys for that. And then I take that and I load it into a simple HTML page that just has to know how to read a REST endpoint, which is pretty easy. So I load that into an open map, and it tells me, a little bit about that. I got more details down here on all of them, but just so you highlight this. You could add as much as you want, whatever I'm sending back over that REST endpoint. So if I wanted to add some more details, what's the destination, what's the name of the line, I could push that in there, though that seems a little much in these little things. And we'd have this continuously updating. So say you had an app, you could have it subscribe to, say, a certain region and just get the points in the map for that, along with the details. Pretty easy, very simple to pull it out of this REST feed that we can continuously populate as that data comes in. So, as more data is coming into the system, we could push it out there. Obviously, with something the size of this, we grab that data continuously and we wouldn't have this thing to slow it down. I can push even on my laptop 5,000 rows a second without a problem. And we could get all those different traffic points in New York and do that real time. That is the major thing, is to get it in here so I can read it as soon as possible and then have something that can join it pretty simply with the data there. I'm storing a bunch of it. I can restart this when I want to look at it, but this is just for me to see it. It's running for all the data coming in, but if you want to see it in the dev tool, you have a little polling here so you could see it to make sure the results are right, especially when you're building new SQL queries against new types of data. And I've got a bunch of different ones in here. And it's as simple as you could do a select star. I can combine different fields together. Again, joins are pretty easy. I can do wherever this data is coming from. And this is as simple as it is to build a table. This happens to be a DB2 table. SQL Server is pretty similar. I create a table here, and now I can use it for insert or select from. So I could just select from a database table as if it was just a regular table, and it doesn't matter. It doesn't matter where it's coming from. I could insert right into a table for something like Postgres. Pretty easy. I'll show you some more slides. Then maybe we'll show a little bit more of the demo. We have some time. Again, if you have questions on, how it works, why should I do it, definitely feel free to reach out. A couple of standard ones here we showed you. Wanted to make sure they're in the slides in case something crashed. So if you want to get to things, all these slides are already posted to the meetup group so that you have them already. I mentioned CDC. I think that's a key element for connecting databases and real time. Is how do I get the data that changes from all these different databases? There's a tool out there in the open source called Debezium that knows how to connect to your database logs, or if the database has a tool that pushes changes somewhere, most of them do. So it taps into that. And as you insert a record, as you update a record, delete a record, whatever you want to watch, that sends an event, a single message, usually JSON, could be Avro, into Debezium. And Debezium can be read by NiFi directly, or Flink directly, or Kafka directly, depending on where do you want it to go first. Like, we can read it right into Flink, and you don't have to use Kafka at all. But generally, people like to get it into Kafka so that I can distribute it to whoever is a consumer right away, and that can be consumed and batched and go to a data store. Some people will use this to publish data from, say, SQL Server on premise to a SQL Server in the cloud. And maybe there's not much in between that's happening. Maybe, something like NiFi or Flink is sitting in the middle to decide, well, maybe we don't put all the data there, or maybe you enrich it, add extra fields, what have you. Maybe do aggregates, depending on what you're using that data for. You can imagine being able to take any change out of your database and do whatever you want with it in real time and then send it to another database or multiple databases. You know, Take Snowflake data, load it into SQL Server, go back and forth, join tables from DB2 and SQL Server in real time, and then insert it into a downstream, iceberg table. You could do that without anything other than SQL and a couple of these things in the middle. Pretty easy to do. To be able to route whatever database to what other database, or to send data. I can join data coming out of S3 with SQL Server, aggregate it, and then send it downstream to Redshift. It doesn't matter. Any of these data sources can be joined once I have them in a standard format. I've got there's videos, the source code, and an article here showing you how to take data from a data store, get that change data capture out, and then use it downstream to do something else. In this example, NiFi stores something in a database, so maybe the initial loading of my data, and then as that insert happens, Debezium's watching those transaction logs, gets a diff, puts it into Flink, and Flink can process this as if it was a regular table. So I could join the CDC that came off of Postgres with a different Kafka topic that's maybe logs, or join the change data capture coming from Postgres with an existing Microsoft SQL Server table, and then insert that into Kafka. I mean, it's mix and match how you want to do this, what database you're using, how you want to do it, but it's very simple within the tool. It's you get the data into a database, and that can be however you normally load your data. My example used NiFi just for ease, and then Flink can read it and read it as it comes in, event at a time. But it can also look back at older data. So once if I want to look at all the data in a table, I could do that. Different ways to do this, pretty straightforward. And creating these tables is just like very similar to creating a table in a database, same kind of DDL, other than we've got a little extra stuff here that tells me what server, how am I connecting to that data store. For Postgres, PG output is how they push out their transaction logs. And we're doing CDC, and I've got login there. Security can be enabled for all these things. And then that's just a feed of data that could have been in that join I have now. I could add one more table, and that's the data coming from SQL Server or Postgres or Oracle or wherever. Very simple to do that. There's no magic for that. It's very, very easy. A table is a table. Again, that big query we just did there. So if you want to try something silly, get at as many fields from the different ones. Again, same idea. The one thing here that's a little different is in between these is kind of like an optimizer hint from the database, but this is adding special options to that data source before it or that table. And this is saying start from the earliest offset. So in Kafka, there's a number associated with everything in that big queue, and that's called an offset. It's the offset from where the current place is. And this is the offset for me as whoever's consuming it, or for this case, Flink is the consumer, and it knows what it's currently at. So when it reads one more, it moves to the next one, keeps moving through, so you don't do things twice. But if you want to look all the way back, I can look back to the first record I ever got and process that. And that's what we're doing in this query, which is why there's so much continuous data, because I've already run this, for hours upon hours and different. So I've got tens of thousands of records in there. So I'll go back to the earliest one to make sure I have something to join here. Otherwise, you see 2 or 3 records and not as much fun. It's nice to see a lot of data flying through the system, but I could decide to make only a left outer join or just a inner join. Again, it's SQL. Do what you want here. I take out a couple of nulls. I can add here, I could do an order by, but order by is kind of weird in this use case, but you could do it. Everything's in version control if you need it. full article on the CDC, which steps through everything. Different examples for different transit systems. They tend to have free public data, which is if you're trying to learn things in different places, whether it's regular data skills or streaming data skills, to be able to have access to data you didn't create yourself is kind of nice. Give some real world applications to that, and that's the main part of this. Now would be a great time for questions. I know we have some time left, and I could dive deep into some other areas or show you some different queries. Do we have any questions?
No questions, at least not in our group chat
Too
yet.
easy.
Yep, people, you set it up, not yet. So I'm sure while everyone's out there checking to make sure they have at least everything they need to understand to do this, I do want to remind everyone that we do have some upcoming presentations for DBA Fundamentals Group. Next week is Automate Deployments with Azure DevOps with Aaron Dempster on February 27th. And then on March 19th is End-to-End SQL Database Development, a comprehensive guide with interactive prompts with Jean Joseph. That'll be about using SQL Server with ChatGPT. So be sure to join us with both of them. But yeah, like Tim said, if you have any questions about Kafka and SQL, that'll be the time to ask.
Excellent presentation. Can you hear me?
Yes.
Yes, we hear you.
Excellent presentation. I don't have a question on the presentation, but where could I make a suggestion for speaking topics outside of this? Because
So
where could I do?
you'd send the email to me at dbafundamentals@gmail.com.
All right. DBAfundamentals@gmail.com. That's it.
That's it.
Yeah, I've been trying to use Azure Data Studio with a Mac using Docker and images, and it seems like that Docker will come out with something and then it doesn't work. So, all right, so I mean, I'm a Windows user by default, but I like to diversify with Mac when I can. So, I'll put that in as a suggestion and see if we can get that to stick. All right, thank you. Very good. Thank you.
Thank you.
All right.
Very cool. I'm trying to think if there's any other magic stuff to show. I mean, this is pretty straightforward. Again, I could pretty much pick up a query, especially if I use database tables as the schema. My Kafka topic will look exactly like the table. So you should be able to take almost any of your queries that aren't doing, there's some specific SQL that some databases have. You might not be able to do all of them, but you should be able to do most of your SQL and move that to the real-time version without changing much. Pick up your SQL, drop it in here, and it'll just run that same way. And if you do things like you want this to go somewhere other than a REST endpoint, I can add an insert like we saw in some of those other queries and just insert into another topic and just grab it from that select statement. Pretty easy. Or I can create a view, same idea you have in regular databases. So it makes it nice to be able to do that without having to change anything really. Same idea. You get your data with the same fields you like, and they can be all different types. I mean, obviously, types that might be where it gets weird. It's usually dates. Dates are the hardest for people. If that's not the case in almost anything in data, making sure you're on the same date format as you might be using could be tough.
Amen. Dates are always hard. I
Dates
see
are
Mark. Mark Davenport has a question. Mark,
Hi,
ask
hi,
away.
hi, hi, guys. Speaking from the UK here, South Wales. So excuse the accent. Probably doesn't fit with a lot of you. So hi, Tim. I was just wondering if
Hey.
the pipeline products and techniques you've just walked us through could be worked in reverse, and that is to use some ingestion tooling to take data from Cloudera back into SQL Server.
Sure, definitely. Yeah, in one in like 2 steps. So literally I can
Okay.
literally just pull it out of Hive, like pull it out of a Hive table and then just put it, it's literally 2 lines. You have a put one and you've got a select one. I don't know if I've got my Hive selected here, but just say it's literally like grab from Hive or Kudu or HBase or HDFS or Ozone, and then just I know I got to put a database in there, sure, and literally connect to Hive or whatever I'm going to connect to, or Hadoop, whatever it is. Do a query and just pull it all in, and it could be querying based on when it changes, or you could do a query like we saw with Kafka. I could pull everything from Kafka. I could have Spark push to Kafka. I could have Flink push to Kafka, have regular database code. There's lots of ways to very easily get your data into Kafka. And
Yeah.
then from there, I think I might have an example for that. Once it's in Kafka, I could pull it out and push it right into your database. So I consume from Kafka and just push it into your database. And again, you could very easily push it to SQL Server.
That's cool. Thanks, Tim. Basically, we've got a bit of a situation. We're stymied by how we move forward. We've got a data pipeline which is part SQL Server, but it's grabbing from Parquet file on Cloudera. Now, over the next year, we're going to be taking the Cloudera part into CDP, into the fully cloud provision version. But there's some strategic changes in SQL Server where Microsoft had decided not to continue supporting external file types against Hortonworks. So we have to think about re-engineering this pipeline. So this is very useful info for me.
Yeah, and we can read Parquet, convert it right into a database, and you don't have to write any code for that, which is
That's
nice.
cool. Thank you very much for excellent advice.
All right, thanks, Mark. I also see Alec has his hand up. Alec, go ahead, ask your question.
Absolutely. Thank you very much. Again, great presentation. I see my question is more geared about the pipeline itself. I mean, we've got SQL schemas, Kafka topic makes sense. That's straightforward. Let's say if I have a pipeline where I'm actually trying to compute the data, right? So let's say it's from 2 columns, I'm going to aggregate something, or a sum of 2 columns, 2 numbers is the third column, something like that, right? Or even if it's like currency lookup, right? Something like that. So I'm just coming up with sample and I'm trying to populate a column. In the pipeline view, I see you've got NiFi here. So obviously NiFi is going to be there's a flow that actually does that. I also see many companies or teams using Flink in addition to NiFi and Kafka. And so my question is more around this group's philosophy or architectural philosophy in what is the role of NiFi? What's the role of Flink? And of course, Kafka we know is just the plumbing at that point, right?
Yes. Basically, it comes down to NiFi is usually the first step. It is ingest the data. Flink doesn't have as many sources to ingest the data. It has some, but not all. NiFi is really great for grabbing any type of data, converting it, routing it, cleaning it up, sending it places. It can do some of that, conversion and lookups like I'm doing here, like parsing documents. If it's documents, if it's images, it's going to NiFi. If it's, if I want to do a lookup against a database, I could do that really easy in NiFi. Flink is I'm joining multiple things. I want to join to various database tables. I want to do some really number crunching. Flink, anything you would do with Spark, you could do with Flink as well.
Right.
Though Spark has some better ML libraries. So, I don't see Spark being completely replaced. You could, but Spark is nice for batch. And, there's a lot of Spark knowledge out there, and the Python support is strong. NiFi has just added Python support. So if we look at some of these processors, they are now written in Python, which opens up a lot of potential options for what you can do with any Python library, especially for things with LLM. But for joining stuff, for doing hardcore number crunching, there's stateful things we could do within Flink that I've got a customer in China who's pushing petabytes of data in real time, and they're doing all the aggregates in Flink, and they're doing some real-time transactions for railroad purchases and travel, and that happens in real time in memory. So I mean, there's Flink. If you've got really hardcore processing, Flink is the place. As big as you want to go, as many things you want to join. Just it's not as easy as drag and drop, and it's not really designed to grab all these different types of weird. Like if I want to grab logs, you could write your own custom code, but this is the way to do that. If I want to grab workday data, want to grab REST endpoints, want to grab messages from Slack and process them as they come through a system, I'm doing that in NiFi. If I want to read real-time traffic cameras, grab the image and process that, I'm probably doing that with NiFi, and then I want to push the results to Iceberg. It's happening there. If I'm doing, like you said, some advanced processing, because Flink, I could also write Java, Python, and Scala code. So if I want to do some hardcore processing, write a Flink app. You're probably not even using Flink SQL. Flink doesn't have to be SQL. It's just like Spark. It could be regular code. Flink SQL just makes it really easy. But you can write, regular applications within Flink, and they get distributed in this same thing where you'd be able to examine the jobs.
Right.
And there's a bunch of different APIs. Hardcore stuff, do it in Flink. Ingest and easy stuff, do it in NiFi. I mean, why write code to do things I could do without code? Because NiFi scales out pretty massive.
Yeah, I would say our teams are, thank you for that. Our teams are probably, within maybe a year into the NiFi Flink stack. So we're seeing a lot of cool stuff. But I'll definitely send an email on that, the Gmail address, to ask for some topics as well. So thank you for that. Yeah.
Very cool.
All right. We have any final questions? Now would be the time. But as always, thank you so much, Tim, for knocking this out. This has been really helpful, I think, getting everybody semi up to speed with Kafka and Flink and all the other kinds of goodness you can make happen. Yeah, so we have about another minute. So if you have any questions, now would be the time to come up with them. At worst, Tim, I'm sure you have some way for us to get a hold of you to ask any questions we have.
Yeah, I take faxes. Send your fax over to my fax line. No, yeah. If you haven't seen me on social media, you're not looking at any data sites. You'll find me on Twitter and way too much on LinkedIn or GitHub. Medium, YouTube. No
Right, you
TikTok
heard,
yet, though.
you heard it here. If you're not paying attention to Tim on social media, you're just not paying attention.
Yeah, I post a lot.
All right. So it looks like we have no further questions. So thank you very much, Tim. This has been helpful and always fun. And let's see, I know someone asked a question. Can we have the Git link in the chat?
Oh, yeah. Get
I
that
think
in
that
there.
would be perfect.
Yeah, I did post that in the meetup group as well.
Awesome. Even more better. All right. Well, thank you so much, Tim. Thanks everyone for coming along. This session will be shared, and I know for sure by the end of the week it will be out there on our dbafuntube.com page. So be sure to watch and like and subscribe, and all will be good in the world. So with that,
Very
thank
cool.
you all very much. Have a great day, and we'll talk at you all soon.